Everyone starts a new system with microservices. Today, we are deliberately not going to, and by the end of this video, you will have this running on your own machine. Splitting on day one means choosing your service boundaries when you understand the domain least. Get one wrong, and a single feature starts needing 3 deployments. So we start with one deployable, keep the boundaries inside it, and split only when something actually forces us to. This is the whole application. One class starts it. Beside it are 2 packages, channel and video. Those are our bounded contexts, and right now they are nothing more than folders. By episode 5, one of them becomes a service of its own. Here is the channel entity. A handle, a display name, a subscriber count. This is a creator's identity on the platform, and it is the piece we extract first because identity is what everything else depends on. Notice how ordinary it is. No interfaces, no abstraction layer waiting for a service that does not exist yet. Adding those now would just be guessing. Now the video entity, and the 3 most important lines in this episode. A many-to-one relationship from video to channel, backed by a real foreign key in a real database. Today, this costs nothing. The database guarantees a video cannot point at a channel that does not exist, and it guarantees it inside a single transaction. Remember this, because in episode 6 these 2 tables move into different databases, and that guarantee stops being free. The controller shows the same thing from the other side. It holds 2 repositories, one for videos, one for channels, and it uses them together. Publishing a video reads the channel table and writes the video table in one transaction. If the channel is missing, nothing is written at all. In a monolith, that is a method call which either works or throws. Once channels live in another service, this becomes a network call that can time out, retry, or half succeed. That is what the saga episodes are about. Enough reading, let's run it. One command, no Docker, no database server, nothing to install first. While Maven works, here is what is starting up. Spring Boot is creating an embedded web server, wiring those 2 repositories, and starting an H2 database inside this very same process. That last part matters. There is no container to launch and no connection string pointing at a server somewhere. The database is a library, running in our application's own memory. A second terminal, and let's ask the application what it actually is. One process ID, both contexts, channels, and videos answering from it, and the database reported as in process. That is the entire platform inside one operating system process. And for a system this size, that is not a compromise. It is the correct answer. Now the join itself. One request for one video, and look at the last 2 fields, the channel handle and the channel display name. Those come from a different table, fetched in the same query, inside the same transaction. One round trip. When channels move into their own service, keeping these 2 fields in this response is going to take us an entire episode. And the last thing a monolith hands you cheaply, tests. 8 of them, against a real database in about 10 seconds. There are no containers to orchestrate and no services to start in the right order. Every one of these tests would need a running system once this is distributed, so enjoy this while it lasts. Watch the bottom line. Build success, 8 tests, 0 failures. So here is the deal we just made. We gave up independent scaling and independent deployment. In exchange, we got one deploy, real transactions, tests that finish in seconds, and boundaries we can still move because they are packages, not services. Everything you just watched is on the branch on screen. Clone it, run it, break it. Next episode, we go looking for the seams, where the bounded contexts actually are, and how to tell a real boundary from a wish.